Hey everybody, this is Brad Dyke saying hi. I am reaching out to you, and today we are talking about something we badly need. We really do need this in today's world. And if you guys have looked at my video that I've done about the fact is we need a new standard for clustering. In other words, bringing resources, compute, RAM, storage, infrastructure, connectivity, into a cluster. It needs to be done better, smarter, cleaner, with less effect, and more universal distribution of workload and capacity. And I did a video on that, and I think it was pretty decent because it's asking for a new way of doing something that we did in the old way. Now, this environment talks about something new that is what actually was brought up I'd say about 10 years ago. It's called Open Infinity Networking Protocol. In other words, OIP. Yeah, actually, OIMP. This open-end Infinity Network Protocol was something that was being developed quite a long time ago, and industry controllers maneuvered to nuke it so they could try to get a portion of the market and control it by offering a lot of added value that actually should have gone into the other solution of the open style Infinity Networking standard. So we still need it. Now, this could be like what happened with storage and how EMC hijacked the storage industry, took away billions of dollars from future growth to pocket in their own money, and eventually realized, okay, everybody's figured us out, and they jumped ship and sold EMC to Dell for a wonderful chunk of cash. I bet those EMC reps are really happy because they pulled the wool over all the people's heads. Some may have seen something what they were doing. But all in general, the truth is they really did detriment the industry by introducing a lot of bureaucracy in the processes of protocols and to basically make storage fall behind, basically. I know that I saw the hardware myself. I realized they were trying to sell stuff that was supposedly microelectronic equivalency, but it was solid state electronics, which is 20 years older. And you just realized, why are they saying this when the truth is that? And, they got really smart. They watched what happened with Data General. They bought Data General, took what they wanted from Data General, buried the rest because it was too open sourced, too open industry standard. Not really easy to make money. And they managed to direct that technology in a different direction. And also they helped break the Infinity standard for networking. Now, Open Infinity standard networking protocol would basically handle all forms of communication protocols, all of them. They would be segmented like ports, like TCP, UDP does, ports. This would actually do what's called a segmentation using something similar to ports, but inside those segmentations of ports are sub-segmentations that give you the ability to introduce security levels. So, for instance, if you had an open network protocol standard, right, and it's infinity, in other words, if you have the pipe, it just fits inside it. It doesn't have to do anything else. It just has to identify that I have an active pipe, it's fiber optic, it's copper, it's whatever it is, I can use it, and I can run many of the protocols, if not all the protocols, if the switch is capable, on that standard. And then there you go. Now you have the 42 to 46 standard ports of types of connectivity. May they be TCP, UDP, SAS, fiber channel, iSCSI, you name it, everything. Every form, ZFS, well, not today's ZFS because that's software. The old days of ZFS, which no longer exists really. And then other, relational style protocols for all IT, not just storage. We can do a lot with such a standard and finally get off of all of this proprietary stuff that Cisco successfully managed to containerize and corral for many, many, many years. And now all of my peers, my counterparts have figured it out. They now understand we don't need any of this. It's just a very simple process. And if you're in your proper port and segmentation and you set your specifics you want for your sub segmentation, you can secure it down like Fort Knox. But that same pipe is running everything. May it be your storage, may it be internet connectivity, may it be NAS protocol stacking, may it be NTCL, it can be DMS, it can be any of those standards, including MPLS. The whole point of it is that the standard is very easy to work with, incredibly easy to work with. Very much how TCP worked. That is a complement to the ICANN environments that now manage those resources where DNSs and binds and so on. The contemplation and the analysis models for doing TCP UDP was brilliant. They got it right. TCP6, still growing pains. They're trying to make it more scalable and more adaptive to on a bigger scale. But it's just not being adopted as well as TCP4 has been so successfully. But the point is that we need a new protocol, a protocol that absorbs all of the older standards into a common form bandwidth. Then at that point stage, the only thing you have to fight is how big is your pipe. That's it. You got 2, 3, 4, 5 ISPs, put it into a trunk, combine them all into an adaptive load balance cluster set, and run all your protocols through it. Talk about terribly simplistically easy to do. All you need to know is the proper address range of the specific protocol you need for your disk storage or for accessing an endpoint or and so on and so on. It doesn't matter. And it would be backwards compatible to TCP/IP and allow the internet to continue to function, but you would genuinely finally have the separation of church and state. TCP here and UDP, everything else here. And that's pretty slick, pretty cool. But anyways, it's a thought to think out. Another thought to think about as well is the nature of plug and play. Now, when I started way back when, in the early 90s, doing x86-based technology as opposed to the AMDOs and mainframes and all that kind of stuff, this new term plug and play came into fruition. And now plug and play has taken a terrible beating. Truly has. I mean, it's just been all over the place and has a very poor success record. But overall, plug and play does exist. For the most part, it's just not being expanded into the next level where CPUs, RAMs, chipsets, and so on can also be adaptive because they contain the critical requirements they need inside the integration itself to be able to say, hey, I am specific make and model, generation, and release. Here's my subcode. You can use me as a device endpoint or whatever I am. May it be a caption card, may it be a CPU, a GPU, and so on and so on. Now, the reason why I bring that up is eventually, as you guys get really good in your lab environments, you'll be able to stack a lot of different motherboards. I did a video on this. I put a whole pile of motherboards, one on top of the other, blah, 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 put them all together and then put them into a stacked cluster. And I was frustrated because even though they are in a cluster, they're not actually sharing resources. Well, with this standard, you could do that because it would just create, your pool is X amount of processors. RAM pool is big because it's going to share between all the different RAM pools at the slowest speed you've got. True, but still, I mean, come on, half a terabyte of RAM is not bad, right? And all the other sub chipsets and the buses interfaces and all that is a huge amount of resource. You can do thousands of USB devices on a stack of 10 motherboards. I think it's 128 devices per stacking per USB bus channel, right? So you've got 10 motherboards and they each have usually 2 to 4 USB channels, depending on their age. That's a lot. And you could plug devices into those and make giant pools of really stupidly slow but functional capacity storage for low basic ended NAS data. And it's just about having to go out and scale the resources in a commonality and do it in a redundant format by default. That's also important. So if you're going to use CPUs, if you have a total of 124 cores, then you pair them, and that means you only have 64 cores that are redundant, kind of like an SMP standard, but you're using it through a software protocol. That's cool. That means you could take 2 standard PC motherboards, use the software protocol, and make an SMP. Sweet. And only the fastest one, who's the slowest, drives the ship. That's right, because if you have a 2.6 gigahertz processor stack and a 2.3 gigahertz stack, you're only going to go 2.3 gigahertz. But you got redundant 2.3 gigahertz. That's that's a lot of saved money. It's just all about thinking about how to make the protocols work. Well, listen, this is just Brad, just spouting off some technology ideas about our future and how we can use standards to invent new standards using old hardware we pull off the shelf and recycle. God bless and have a great week. Take care.